Dear colleagues, I am Aziz Nuriyev from Azerbaijan. I want to present my contribution, named Fuzzy Multi-Criteria Decision-Making Models for Selection of the Tourist Development Site, the case of Azerbaijan. This is brief information about me and my research interests. And in the beginning, I will give a brief overview of my work by presenting an abstract of my paper. The 3 slides highlight the main ideas about what motivated us to do this research, the main methods, results, and conclusions. We used the extension of fuzzy logic. We used a Delphi panel for model development, and we used fuzzy Z-information-based TAPSIS and Prometheus methods for the problem solution. We defined 6 criteria. We used 2 approaches. We used direct calculation with the numbers, and methodology of decision making under high level of uncertainty was suggested. As I mentioned before, tourism site selection study is a very important issue for the tourism industry in developing country. There are many tools for auditing the potential location, but development of tourism in such countries, including Azerbaijan, has its own specifics. Simple copying of methods does not provide a relevant result in all cases. Moreover, the paradigm of sustainable tourism development requires a flexible combination of scarcely compatible requirements, such as maximizing socio-economic benefits for environment, society, visitors, cultural heritage states, and minimizing negative impacts. Analysis of literature shows that there is a time lag between tourism site location studies carried out in developed and developing countries. The slide highlights the main differences between studies in different countries. Multi-criteria decision-making approach allows considering together a set of alternatives, factors, contradictional criteria, and widely used for location selection, for energy generation, logistics, public services. The tourism sector and in hospitality industry are also successfully using multi-criteria analysis for managerial decision making. The selection of the location for the construction of the tourism and hospitality objects is one of the complex managerial multi-criteria tasks that has become increasingly important in recent years in developing countries. It is directly related to such factors as growth of tourism, the high competition, the necessity for new approach to the creation of hospitality facilities, and the increasing sophistication of the tourism development location selection decision. Decision-making in tourism, even in developed countries, often occurs under conditions of uncertainty, based on imperfect information. In the tourism are often arising situation associated with inaccuracy, incompleteness, or partial reliability of information available for decision making. These specifics are generated by involvement of various actors in this sphere and the impossibility to describe all processes and components by perfect information. In case of developing countries, the level of uncertainty increases even more because the statistical apparatus for such territories is not fully formed. In addition, in some cases, it is difficult to find out the dependency between tourist flow and infrastructure or social economic factors by applying statistical analysis. The need to make decisions based on the available data without adequate statistical history, as well as combination of qualitative parameters with quantitative information, necessitate the involvement of experts to obtain aggregate estimates. What does it mean? Aggregated linguistic assessment allow decision makers to get more adequate idea of the task being solved, especially at the initial stage or meta level. For example, if we are speaking about distance, the distance to the object can be estimated by many people on the map. However, aggregated expert assessment of accessibility, including distance, road quality, traffic density, accident rate, the presence of carriers, etc., make it possible to assess the situation more adequately. To formalize high-level uncertainty in decision-making models, it was suggested to use Z-numbers introduced by Lotfizadeh. What is Z-numbers? On this slide, you can see the answer to this question. I want to clarify some moments. Paths A and B have a certain relationship with each other. Analysis of tourism shows that there are many examples of use of information that can be best described by Z-numbers. For example, when we are speaking about tourism flow, for example, we want to estimate tourism flow in the next quarter, we can use Z-numbers very good. Tourism flow is the next quarter, decrease probably, or healthcare status in some country, healthcare status equal high, very likely. Having given the numbers, we also have the apparatus and axiomatics of direct calculation with them. Unfortunately, due to time constraints, it is impossible to discuss now and to share with you this very interesting topic, but I can answer to your question by email every time. Analysis of recent research studies shows that for location selection tasks, the following multi-criteria decision-making techniques are used: distance-based, pair-wise comparison, outranking, and scoring method. Therefore, for tourism development site selection, two well-proven approach from different groups of techniques, namely distance-based method TOPSIS and outranking method PROMETHEE, were chosen. Since decision makers and experts will use Z information in the decision process, the method used will be Z-TOPSIS and Z-PROMETHEE. Also, there are publications in the literature on the use Z-TOPSIS and Z-PROMETHEE. Most of implementation are oversimplifying method when Z numbers, Z information is converted sequentially to a fuzzy number and then to a crisp number. A reasonable question arises: why to use Z numbers if various conversions is carried out and this conversion distort initial information? Application of classic and fuzzy TOPSIS are widely present in research paper. Next slide briefly outlines the features of this method application in case of use Z numbers and direct calculation with Z numbers. Classic and fuzzy parameter also widely used for multi-criteria decision-making tasks. And let us briefly outline the features of the extension of this method based on the direct calculation with the numbers. Determination of criteria is one of the key stages in multi-criteria analysis. The numbers reflect the opinion of experts in natural language and those contain more complex information. Since most often weights are assigned based on intuitive understanding of the relative importance of criteria, and use of the number allows expert to express his opinion in a way convenient for him. More the numbers allow to express the opinion of a group of experts more adequately. In this study, to reflect linguistic experts' assessment about weights, the usage of the numbers-based swing method is suggested. This approach consists of several steps. The numbers based swing matrix is built. The criterion that is very important for decision making, and there is a great confidence in this, will be placed at the upper corner of matrix. As in the case in traditional swing weight matrix, the rules are set to ensure the consistency of the numbers based weights. For example, according to these rules, C4 criteria dominates C7, C3, and C6. The criteria placed in the cells of the matrix according to their importance values and degree confidence in them. Person assigning weights to the Z numbers must evaluate trade-offs between level of importance and level of confidence. It should be noted that non-normalized important weights are obtained at this stage. Weights should be normalized according to below formula. In example, the normalized weights of criteria C2, you can see the formula about this criteria. I want to give a brief information about Azerbaijan Republic. We will study 5 regions attractive for tourism develop, 5 regions and districts within each region. To identify the criteria, a group of 9 experts from tourism sector, state agents and university was formed to evaluate them and determine the degree of importance in this criteria. On this slide you can see the final decision of Delphi panel, 6 criteria. Let's consider each of these criteria separately. Economical criterion is an integral assessment of the volume of necessary investment, which at this stage of decision making are expressed by linguistic values: large, significant, average, based on the cognitive ideas of expert. Each expert has its own semantic of these values, but there are some general ideas. For example, if volume of investments is 50 million manats, 29 million US dollars, then almost all experts will agree that linguistic value of this criterion will be high or very high. The criterion recreation and tourism resource availability is integral assessment of availability and condition of natural areas, forest, mineral waters, and man-made resources. Accessibility criterion is related to the presence of and situation with roads and railways, air traffic, as well as ability to access this place regardless of natural condition. Ecological and environmental attractiveness implies considering the ecological possibilities of a region. Utilities availabilities provide an integrated assessment about water, electricity, and gas in given region. These components play a key role in economic and social life of region. Human resources include the availability of the necessary labor force for development activity and for site maintenance. After defining criteria, the expert evaluates each of 5 regions according to this criteria using the numbers, and slide shows the decision matrix. Moderator also estimated the competence of expert using the numbers. Weighted value of competence is calculated by following formula. For constructed z-number based normalized decision matrix, the appropriate values from decision matrix multiplied by the competent weights of expert, and then decision matrix is normalized. The results are shown in this table. After discussion, the expert group constructed consensus-based swing weights matrix. The weights of criteria expressed by z numbers are calculated according to before mentioned formula. The results are shown on slide. After compilation of normalized decision matrix and the table of criteria weights, the following weighted normalized decision matrix is constructed. Next step, calculation of the distance from each alternative to ideal positive and ideal negative solution, and calculation the relative closeness to the best alternative. As ideal points, we use those indicated on the slide. And then ranking of alternatives with relative closeness. And we obtain the following order of alternative: A1, A4, A and A5, A3 and A2. High priority has alternative A1. Z-Prometei based solution. First step, determination of the differences between alternatives according to the criteria, and calculation Z-valued based preference function. Z-number-based weighted preferences are obtained by multiplying the appropriate values of preference function at the number-based weights of criteria. As a result, we get following table of weighted preferences. Then next step, calculation of the leaving and entering flows for each alternative, and next step, calculation of the net flows. The results of calculation of the net flows are shown in the table. Ranking of the alternatives with the numbers based values of net flows. We obtain the following priority order for alternative A1, A4, A5, A3, and A2. Six important criteria are used for decision making on selected suitable region for tourism development. Results of research allow to identify 3 regions of Azerbaijan that are most suitable for the tourism development, namely Shiki-Zakatala, Guba-Hachmaz, and Karabakh regions. The study showed the importance of such natural-based criteria as environment, ecological attractiveness, recreation, and tourism resource. In this slide, you can see the main ideas of our research. 2 models was based on UZ numbers were developed. Developed model based on experts and decision making knowledge. It is very important moment. Z numbers allow experts to express factors in terms of natural language, for example, high, very likely, or low, extremely likely, etc. Z numbers used for criteria weighting and evaluation for estimation of expert competence for decision matrix construction, for evaluation alternatives according to the criteria. 6 criteria was defined, and importance of natural-based criteria, environmental, ecological attractiveness, and recreation and tourism resource importance is defined. Implementation of direct calculation techniques with Z number allows to solve decision-making task without transformation that distort the original information and, as a result, affect the final decision. Within approach, the new methods for normalization of the number-based decision-making, the number-based swing matrix for determining the criteria importance weights are suggested. And we sure that the creation of user-friendly web software will make it possible to take advantage of Z numbers more widely for managerial decision-making in various areas. The effectiveness of Z numbers, the research has shown the effectiveness of Z numbers. We got the same ranking of alternative for the both different methods, distance-based and outranking method, by using Z numbers. That's all. Thank you very much for your attention and patience. I am always ready to answer your question. You can send questions to my email, and I wish you all good things. Thank you very much. Goodbye. Thank you very much.